Okay, this is section 2.1, Patterns and Inductive Reasoning. So when we finish, we're going to be able to use inductive reasoning to make conjectures. Now, what is inductive reasoning? So inductive reasoning is reasoning based on a pattern that you have observed. So once again, inductive reasoning is reasoning that's based on a pattern you have observed. Now let's see if we can find a pattern in this example. We have the numbers 3, 9, 27, and 81. So let's see what we can find. So 3 to 9, we multiply by 3. Let's try this out. 9 to 27, we multiply by 3. 27 to 81, we multiply by 3. So notice how I found the pattern really quickly. All of the patterns aren't going to be so obvious. So just be careful with that. So our next two numbers are 243, and 243 times 3 gives me 729. Now let's take a look at this example, which is only figures. So I start out with a triangle. Next I have a square. Then I have a pentagon. So we have a 3-sided figure, a 4-sided figure, a 5-sided figure. So I am going to guess that our next one is going to be a 6-sided figure followed by a 7-sided figure. So in a question like this, you would either draw the next figure or select from multiple choice. Okay, so now we have another vocabulary word, conjecture. Conjecture is a conclusion that you reach using inductive reasoning. So conjecture is a conclusion that you reach using inductive reasoning. So let's take a look at this example. We're going to look at the circles, and they want to know what conjecture can we make about the number of regions that 20 diameters form. So here I have 1 diameter. How many regions are formed? 2. Here I have 2 diameters. How many regions are formed? There are 4. Here I have 3 diameters. How many regions are formed? 6. So it appears that for each diameter, the number of regions is double the diameter. So when I have 3, it's 6. So when I have 20 diameters, that should be 40 regions. This is much more efficient than trying to draw 20 diameters. Okay, so this example, it wants us to collect information to make a conjecture. So what conjecture can you make about the sum of the first 30 even numbers? So I don't know about you, but I'm a visual person, so I need to draw that out. So I'm just going to make a little table. Do like my number of terms, then what the terms are, and then the sum of those terms. So with one term, it's the first 30 even numbers, so that's 2. So 2 plus nothing gives me 2. 2 terms is going to be 2 plus 4, so that's going to give me 6. 3 terms is 2 plus 4 plus 6, which gives me 12. 4 terms is 2 plus 4 plus 6 plus 8, which gives me 20. So you might be seeing a pattern now, but just in case you're not, we can do 5, which is 2 plus 4 plus 6 plus 8 plus 10. So this one is going to be 30 when we add all of those up. So let's see if I can see a relationship between the number of terms, and the sum. Okay, so 1 and 2. Okay, that's 1 times 2. 2 and 6. Oh, well, that's 2 times 3. 3 and 12. Oh, this one is 3 times 4. So it's the term times the next consecutive number. Let's try that out. So fourth, 4 times 5. Oh, that gives me 20. 5 times 6 gives me 30. So for the 30th term, it's going to be 30 times 31, which gives me, the sum would be 930. See, in this example, they give us a chart. They're looking at a decrease in sales from backpacks. So sales of backpacks at a nationwide company decreased over a period of 6 consecutive months. What conjecture can we make about backpacks, about the number of backpacks that the company will sell in May? So we can see that it's decreasing. About how much is it decreasing from month to month? So if I look over here, like this month it's larger, but for the most part, they're close to 1 unit apart. So this would be, so it looks like it's decreasing by approximately 500. So what were the sales in April? Well, if I look over here, April sales are a little less than 8,500. But we're not looking for an exact number. We're just making a conjecture. So if they're decreasing 500 units per month, in May, the sales should be around 8,000. Now, can we use this graph to make predictions for sales in July and August? So it's got November through May. So I'm going to suggest that this data would not be good to use for prediction of sales in July and August. What's one reason? What happens in July and August? We start back to school shopping. So that could have an impact on the sales. Now, as hard as we may try, all of our conjectures are not going to be correct. So a counterexample is an example that shows that a conjecture is incorrect. And it's really important to remember is that it only takes one counterexample to show that a conjecture is incorrect. It can't be, well, it works most of the time. It's either a true conjecture or it's not. There's no in between. So now we're going to find counterexamples for the following examples. So if the name of a month starts with the letter J, it is a summer month. Well, I can think of one right off the top of my head. that is not a summer month and begins with J. January, and it's a winter month. You can connect any 3 points to form a triangle. So I can put these 3 points together, but I can think of another example where they do not. So if they are all on the same line, they do not form a triangle. And last but not least, when you multiply a number by 2, the product is greater than the original number. So what if I multiply -4 times 2? So that gives me -8, and -8 is not greater than -4. So one of the hardest things to do is going to be to let go of any preconceived ideas or assumptions. Once you do that, finding counterexamples will be much easier.